add to it tonight, okay? You'll just add to it a couple more problems. So where we left off here is at getting to the sum of the finite geometric series. When we get to the sum of the finite series, we have another formula. Now, what this means again is we're going to add up a bunch of terms in a geometric series, and this is how we come up with the formula that what it's going to equal, if you will. Just like it was with the sum formula for the arithmetic, the sum of however many you're looking to add up together, the n value here stands for the number of terms within the sequence. You still have that r value as your common ratio. It's always going to be equal to that first term times a whole bunch of junk. It's really not that bad though, okay? It's 1 minus whatever your rate is to however many terms you're trying to add up. So if you're trying to add up 7 terms, your n value is 7, so your rate to the 7th power. That's all that stands for. All over 1 minus your rate. Now, when you're working with these rate stuff, sometimes remember you're going to get decimals, fractions, and whatnot. It's just a matter of being able to use your calculator to put them together, okay? Using the fraction bar and things like that. In all honesty, it's not a very difficult formula to use. What's going to be the difficult part is the working backwards. That's where there's a little twist that's going to happen today that you have never seen before, but I'm going to show you how something works, okay? All right. So let's look at this. Oh, it's right here. I just left it here too. Okay. Because I'm just going to refer back and forth to it. I'll go for it on Friday. You guys didn't get rained out. Bless you.
We got second.
Nice. Why didn't you win?
Because the team that won had to sneak to share.
Didn't you wear your clothes? All right. So let's take a look at this sequence. I'm going to start with something pretty simple here. 1 plus 5 plus 25 plus 125 plus 625. Could you probably tell what your rate is? That's 5 times 5. Good. So when we start this stuff up, we're going to start by writing out the sum of the first 10 terms. So let's write out a sub n. We're going to write out our generic rule first. Our first term, r to the n minus 1. I want to keep getting the habit of writing that out because when we get into what we do in 11.5, we're going to write what's called a recursive rule. And that's a rule on how you can relate things to the previous term. And you always want to write out a generic rule first, the explicit rule, if you will. Okay? So this is a very easy formula to write out. We know that the nth rule is the first term of 1 times 5 to the n minus 1. It's a very easy formula to come up with. Does everybody agree? Yeah. Okay. Therefore, we know that our rate is 5. We didn't have to do a lot of math here to figure that out. So if we want to find the sum of the first 10 terms, that means our n value is going to be what? 10. So the sum of 10 terms is going to be our first term times 1 minus the rate to the 10th power, because we want 10 of them, all over 1 minus the rate. So fill in the blanks. Our first term here was 1. 1 minus 5 to the 10th power. In this problem, it's the 10th power, that too, because it's asking for 10 terms.
Okay.
Sometimes it'll ask you for 8.
So it depends on the number.
Yes, sir. Okay. And then it's just over 1 minus 5. And you'll notice that this is a very simple thing to add in your calculator. With the initial term being a 1, do I even need to put that in my calculator? No. So what I'm going to do is create a fraction bar right off the bat. I'm going to create the fraction bar, alpha y equals, and hit enter. Everybody okay with that? 1 minus 5 to the 10th power, all over 1 minus 5. So if you add up 10 of those values in that sequence, you get that. Not bad, right? So you guys were sitting there going, oh no, that's a scary formula. Oh. It's a scary number. Okay. Yes, ma'am. The rates in this case, if you look at each one of these, go from when you take 5 divided by 1, 25 divided by 5. Remember, we're talking about geometric. We're looking at you're taking the second term divided by the first, and so on. Okay. And this one is very easy. So now comes the curveball. How many of these do we have to add up together to have it equal 3,906? How many of these terms in the sequence find n such that the sum of them is going to equal 3,906? It's going to be like thank you. It's going to be less than 10. Good. So the sum of them, remember it's the first term, 1 minus r to the n over 1 minus your r. We know what our first term is, and we know what our r value is. Do you agree?
Yeah.
Okay. Fill in the blanks. So we have, it was 3,906, correct?
Yeah.
Equals 1 times 1 minus 5 to the n over 1 minus 5. No. I need to get rid of, well, can I just not worry about that 1 out front for right now? Okay. Does everybody agree that the denominator equals -4?
Yes.
How do you undo divide by -4?
You multiply by negative.
Good. Multiply both sides by -4. I'm just going to do that right away.
Because of
So what's -4 times 3,906?
Negative
15,624?
Yes.
Thank you, sir. Equals 1 minus 5 to the n. Everybody okay with that now?
Yes.
All right. Now, here's a little bit of a twist. I want to get that, see how it says -5 to the nth power?
Yeah.
I want to make that positive. What do I do? Can I just add that to the left side?
Yeah.
I'm going to add that to the left side, and at the same time, I'm going to add the other stuff to the right side. I'm flipping a ruin.
Yeah.
So I'm going to get 5 to the n is 15,625. Now it's where it's something you've never done before. What's 15,624 plus 1?
Oh, okay. Never mind. All right, I got this. Didn't see that.
Okay. Let me ask you this. What's 5 squared? What's 5 cubed?
125.
Now, here's where things get interesting. In order to figure out what 5 to some power, let's say, equals 90, that means we have to figure out that there's some number that if I rate 5 to that number will have to equal 90. Do you agree? It's got to be somewhere between 2 and 3, correct? But I don't know what it is. So this is another way of undoing an equation that you have not seen before. You guys all know that undoing, multiplying, you divide. Undo adding, you subtract. Undo squaring, you square root. Undo cubing, you cube root. Things like that. When we're raising things to exponents, to undo an exponent, you log. Log, it's big, it's heavy, it's wood. Log, it's better than bad, it's good. No? Nobody?
I've heard it before, but I know what it is.
Here's what happens. What you want to do here is there are things called bases and exponents. A logarithm is nothing more than base and exponents. It's how you can write things in with a different base number, which in this case would be a 5, to some power. In your calculator, there is a way to do this. What we're going to do is to undo 5 to the nth power we do the following. It's called log base. We log base 5 of 5 to the n. By doing a log base 5 of 5 to the n, that log base 5 undoes the 5 and it allows the n to drop. Did I say undoes? It undoes it. We failed English. So if I log base 5 on one side, what do I have to do to the other? Log base 5. So that means I have to take the log base 5 of 15, 6, 25. Just wait. Relax. There is a button. Alpha window, I believe. Number 5, you see that says log base? Alpha window. Number 5 says log base. Everybody see that? So all you have to do is type in number 5, and then all of a sudden it shows you log, and it's blinking the cursor on the base that you want it to be. What's the base I want it to be? 5. And what do I put in parentheses?
Wait, I got
5. Oh, never mind. Oh, okay.
Or 1. Oh.
So that means 5 to the 6th power is 15, 6, 25. Did you not get, is it not on yours? Oh, you just didn't. Okay, when you hit 5, and this would hit a arrow into it. Does that make sense? So what's going to happen here is this question was asking you, how many terms within this sequence would you have to add up to equal 3906? I have to add up 6 of them. That's what that means. That's where this log base comes from. Does it work? Okay. Bad? You can kind of guess ball a lot of it, yeah, but sometimes it's, well, yeah, true, but now you know the right way to solve it. Oh. So try this one. Yeah, same basic principle, guys. I'd like you to find the sum of 14 terms. After you do that, I'd like you to figure out how many in that sequence would you have to add together to equal it to be 341. Okay? Using that log base trick that I just showed you. Yes, there are full chapters in this book about logarithms and things like that, and exponent rules. Oh, absolutely. It just so happened, like I said, we're so out of sequence with stuff right now, there are little things I have to show you how to do as we go along. Just not a big deal. So take a couple minutes if you figure that one out.
Wait, so the one that you put in the base for the log is whatever the
Yes. Yes. That's a nice thing to remember. Did you get for part A really big number?
Yeah. Yes.
Part A's answer is really big number with like an 8 in it?
Yeah.
All right, you did it just fine. Okay. Now, part B, when you set it up, remember, the sum is first term, 1 minus r to the n over 1 minus r. Was 341 is 1 minus 4 to the n over 1 minus 4. I didn't put the 1 out in front because I really don't need it. So multiply both sides by -3. -1023. I'm going to move that to the right while moving the 4 to the end to the left. Is it 6? 5? Yes, ma'am. I want base 4 of both sides. So, I'm adding a new what? Are you gonna do a negative? Hey, a really nice trick to remember here, guys, a nice trick to remember is that your n values, when you take the logs, they've got to be integers. They got to wind up being integers because that's the number in the sequence. How many of them within that sequence would you have to add together? Well, you can't add together 4.3 numbers within the sequence. You can't add up. You have to add up 1 term, 2 terms, 3 terms, 4, 5 terms, 6 terms, 7 terms, more. I think that was from Friday. Not so scary?
Very scary.
It's not very scary. What we got? 16. Okay. Let me show you the other part for today then.
I really hope that we're not doing
No, I want to show you the other part I want to look at today. Some of you guys were asking about it. I'm going to blend in just a little bit of 11.4. Now, we talked about summing finite series. What if I told you you can still find the sum of an infinite series? How?
I guess it's not.
It's not, because what happens is there's approximations of what is it approaching.
What does that mean?
What's half of 4? 2. What's after that?
1.
What's after that?
1,
What's
5.
after that?
1, 2, 5.
Isn't it always continuously getting smaller and smaller and smaller? It's like, I'm not touching you, 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 I'm not touching you. You're always going to get infinitely closer and closer and closer and closer until you do, but you still can get closer.
Yeah.
Right?
Yeah.
Thank you. So here's what happens. What happens if you want to find the sum of an infinite geometric series? If I want to find the sum of an infinite geometric series, this only works for geometric.
Wait, are we in 11?
Yeah, I'm going to mix a little bit of 11. This is just one very short bit of 11.4. It's very short. I'm not getting too involved with it. Just a quick example here. Yeah. Yeah, it's a very easy thing to work with. So what happens if you have a sum of an infinite series, if it's geometric, the first term of the R value, your rate, the absolute value of the rate, has to be less than 1. That's the only type of infinite series we can make this work. The rate has to be less than 1. Okay? Yeah, that would be less than 1. But it has to be less than a value of like 1/3. It can't be 3 halves because that's more than 1. Okay? So what happens here is, as long as there is a rate, an R value that has the absolute value between of less than 1, this works. And I'll show you an example here in a second. So to sum an infinite series, notice there's no n value there because it's implied that the sum is infinite. The sum of an infinite is just the first term over 1 minus the R value. It's very easy to work with. Let me show you how it goes.
Wait, go back.
It's right here. R has to be less than 1. Absolute value of R is less than 1. Otherwise, it doesn't work. Okay. Now, when I'm looking at this in terms of how a lot of it's written out, a lot of times this is written out in summation form with that big giant sigma. When you have the sigma value, that means the sum, 1 through infinity, that means you find an infinite sum. And then they write it out as an nth rule. They'll write it out that looks like a sub 1 times r to the n minus 1. You just have to be able to pluck out the r value. Very easy to distinguish. In this example here, what's your r value? 0.7. What's your first term? 3. My first term here is 3 because this is our a sub 1 and this is my r value. So the sum of this would be first term over 1 minus my r, which is 3 over 1 minus 0.7. 10. All you're doing is put it right in the calculator. That's all it is. There's no infinite button. There's no nothing. And this is what you guys remember at the beginning of this chapter. You guys were asking like, well, how can you add up all these things that are infinite? Where's the infinite button? Well, there's a rule, and it only works for the geometric, and the rate has to be or has to have an absolute value less than 1. If it doesn't, you can't do it. Okay? And that's all this is. It's that straightforward. I can't throw any other curveball at it. As long as the r value is less than 1, you're fine.
It is.
Right? You didn't trust me?
It's embarrassing.
Okay, take a look at this. If I wanted to find the sum of that, what are the two things I have to first figure out? First term and the rate. So, in order to find the sum of this, I got to find the first term and my rate. Well, what's my first term here? 1. What's my rate?
Negative
Can I write negative 1/4 or negative 0.25? Does it matter which one I use? To be honest with you, sometimes when you're dealing with very easy fractions, halves, quarters, if you want to use the decimal in the calculator, by all means go for it. It's just quicker, less buttons to press. And now I know enough information to write it out. It's 1 divided by 1 minus a negative 0.25. 5/4? Is it 1 1/4?
It should.
I don't know. I don't remember.
Yeah, it is.
5/4?
No.
Wasn't it 5/4?
Yeah.
I got 0.8.
Oh, 0.8. 0.8's not 5/4. 4/5. Thank you. Yeah, that's right. 5/4 down here. Yeah, it's 4/5.
For the number that's on the right, what's that?
That's the R value. The R value, remember, is that is the generic rule here. That's this right here.
Oh, okay.
That's all that was. It's the explicit rule for the geometric sequence, if you will. All right? So today you've got solving the sums of the geometric that have finite, and I'll give you some solving the sums that are infinite. Remember, if that R value happens to be greater than 1 of an absolute value, what do you say? No. Say no. And the reason is R is greater than 1. Just say no. Don't you bad. Okay? Let me give you a couple of these to try. Homework. So this is 11/3 and 11/4.
So is this just going on the same sheet or?
Yeah, I would just throw them on the same sheet. That's fine. We'll do 52 and then. You didn't do 52 though, right? No, I just want to give you guys another practice one of those.
I think 8.
Okay?
Even.
Yes, ma'am. Fill out your agenda, okay?
It's a lot of homework.
It's not a lot of homework. Okay? You guys got 10 minutes to get going on it. You can get that first chunk of these things done. There's the, that's the 11. I don't want to stop them going out for you. Yes, ma'am.
I still don't understand the 11 to 4. Like,
Which one's the factory part?
yeah, it's like, they were all 5-3. Or security. Stressed.
I feel like that's a lot.
I mean, it was a little embarrassing.
I think that's like really dumb. Like, why? Who cares? Do it.
It's not working on this. Oh, there we go. Almost did, but
Like, they do a lot.
yeah.
I think they might be sad. Yeah. I really, but there's
It's usually that sad. Sorry, I had to write it all.
Stop.